Assalamualaikum warahmatullahi wabarakatuh. Now we would like to present our slide is off-grid photovoltaic OGPV system in Malaysia, presented by Group 6. Firstly, I want to introduce my group members. First, Pritiba Raj anak lelaki Kumaran, and the second Muhammad Afif Azri Sharza bin Muhammad Aizul, and the second Afiq Rushdi bin A.S. Azman, and the fourth Nur Aiman Harith bin Hazrul, and the last one is Nur Aisyah Balkis bin Muhammad Zainan. For introduction, we go through to what is OGPV. An off-grid photovoltaic system is a standalone solar energy system that operates completely independent from the national electricity grid. It generates electricity using solar photovoltaic panels and supplies power directly to users without relying on utility companies. OGPV systems are specially designed for remote, rural, or geographically challenging areas where extending the national grid is difficult, impractical, or too expensive. Examples include deep jungle areas, isolate islands, mountainous regions, and remote villages. The electricity generated from sunlight is usually stored in batteries so that power can still be used during nighttime or cloudy weather. This makes OGPV system a reliable renewable energy solution for locations without access to grid electricity.
Next, let's look how OGPV actually works. Because it is completely disconnected from the main grid, OGPV really relies on the energy storage system, which is battery. During the day, the solar panel generate current, direct current, DC power. This power is managed by the charger controller, which is safely route the energy to charge the battery, so we have power at night or on a cloudy days. To visualize the flow, here is the key component. Energy start from the solar PV array, pass through the charger controller, and it stored in the battery bank. From there, it goes through to the off-grid interval to convert into a usable AC power, and finally it power the electric load on our application. Now, we will moving to the energy policies current trend in Malaysia. When it comes to the national policies, the adoption of OGPV is strongly driven by the Rural Electrification Programme or Bekalan Elektrik Luar Bandar. This initiative perfectly aligns with our National Energy Transition Roadmap (NERT) to achieve the universal electricity access across the country. In terms of current trend, we are seeing a major shift toward the solar hybrid system. This approach combines OGPV with battery storage and backup diesel generator. The goal here is to ensure a uninterrupted 24/7 power supply for the remote communities, orang asli, settlement, and eco-tourist island, particularly in Sabah and Sarawak.
Assalamualaikum, my name is Nur Aisyah Balkis and I will explain about the issue and challenge of OGPV system. First is the issue of high upfront cost or capex. This initial investment for OGPV is much higher compared to normal grid-tied solar system. This is because OGPV require additional components such as battery storage system and charge controller. These components are expensive, especially for large-scale installation in remote area. Another important issue is e-waste management. Over time, battery, especially lead-acid batteries, will degrade and need replacement. However, many remote areas still lack proper recycling and disposal facilities. Improper disposal can cause environmental pollution and create health risks for local communities. Now, moving on the challenge of implementing OGPV. One major challenge is logistical barrier. Transporting solar panel, battery bank, and other fragile equipment to remote location is difficult. In Malaysia, some rural areas are surrounded by dense forests, mountains, or isolated islands with poor road infrastructure. This increases transportation costs and installation difficulty. The next challenge is operation and maintenance, or OMM. Many rural communities lack trained technicians with the expertise to troubleshoot, clean, and maintain the system properly. Without a regular maintenance, the performance of the OGPV system may decrease and can lead to premature system failure. The final challenge is climate constraint. Malaysia experience frequent monsoon season and heavy cloud cover throughout the year. This weather condition reduce solar irradiance, which directly affect the efficiency and reliability of solar power generation. In a nutshell, although OGPV offer great potential as a renewable energy solution, several issues and challenges such as high cost, e-waste logistics, maintenance and weather condition must be addressed to ensure sustainable implementation. That's all for me. Thank you.
Okay guys, next slide, let's look about advantages. When we look at deploying this system, they offer three massive advantages. First, energy independence. It grants complete autonomy to rural communities, requiring absolutely no connection to national utility provider like TNB, SESB or SEB. Second, it is environmental friendly. The system produces zero carbon emission and operates silently, which is massive upgrade over the loud polluting diesel generator traditionally used in remote areas. Finally, no utility bills. It entirely eliminates monthly electricity costs and completely insulates vulnerable communities from fluctuating fossil fuels prices. Advantages. However, engineer and off-grid system comes with distant trade-off that we must manage. The first challenge is strict load management. Because energy is finite, users cannot freely run high-power applications like air conditioners or heavy heaters without rapidly draining the system. The second is battery dependency. Operating at night relies entirely on energy storage. These batteries are not only bulky and expensive, but they also require a strict replacement cycle every 3 to 10 years, which adds to long-term maintenance logistics. Balancing these advantages against their operational constraints is key to design sustainable life and changing energy solution for Malaysia interiors. To understand the real-world impact of off-grid solar photovoltaic system or OGPV, we first need to look at the broader landscape of energy access in Malaysia. According to World Bank data, Malaysia have achieved an impressive 99.78% national electrification rate. It's an incredible milestone, but it leaves a critical gap. There remains 0.22 of populations. As you can see, highlighted on the map, this off-grid population is permanently located in the deep, remote interiors of Sabah and Sarawak. For these communities, extending the physical national grid is structurally and financially impractical. Therefore, OGPV stands out as most viable and critical solution to bridge the final gap and achieve true 100% electrification.
Hi, my name is Nur Maharib bin Hazrul and I will explain about fact, figure and reference. So, the fact is the global levelized cost of electricity, or we call it as LCOE, for newly commissioned solar PV project that plummeted by 88% between 2010 and 2021. This have a massive cost reduction that has made OGPV system that financially viable for rural electrification compared running diesel generator full time. Okay, let's see the graph, which is in 2010 we need almost $40 to generate electricity, while at the 2021 we cost nearly $5 per kilowatt to generate electricity. So this reference is basically at International Renewable Energy Agency, or we call it as IRENA, and renewable power generation cost in Abu Dhabi. So what is previous, current and future? So previously we used engine diesel to generate electricity, and basically highly polluting the environment, noisy and required expensive machine. Also required fuel transportation for transport the generator to generate electricity at the small area. And currently we use widespread use of standalone OGPV and solar high diesel hybrid system that paired with high lead acid or lithium ion battery storage, basically in the special room to that less pollution and almost 0% noisy. So in future, we target smart microgrid that OGPV system will integrate IoT for remote real-time monitoring. Also, AI also predictive maintenance and advanced energy storage, such as solid state batteries, for longer lifespan and greater efficiency. That we try to reduce the pollution for environment. So, in conclusion, off-grid photovoltaic, or as known as OGPV, system has served that almost critical solution to electrify the remaining of 0.22% of off-grid pollution in rural Malaysia. Also supported by 88 plants in solar technology, costly and high efficiency advancement in silicon solar cell. So, the future transition from diesel to IoT integrated like smart microgrid will not only resolve operational challenges but also support the national energy transportation roadmap, or we refer as NETR, aspiration toward net zero carbon in future, which is we care about our environment and try to live health.
In conclusion, off-grid photovoltaic or OGPV systems have become one of the most effective solutions for supplying electricity to the remaining 0.22 of off-grid population in rural Malaysia. With solar technology costs decreasing by 88% and continuous improvement in silicon solar cell efficiency, such as mono-C and PERC or TOPCon technologies, the implementation of these systems is now more practical, reliable, and sustainable than ever before. Furthermore, the future shift from diesel-based system to IoT integrated smart microgrids will help overcome operational challenge while supporting Malaysia's National Energy Transition Roadmap or NETR toward achieving a net zero carbon future. Therefore, OGPV systems are not only a technological solution but also a crucial step toward sustainable rural development and clean energy transformation in Malaysia.